All right, so the last section of chapter 4 is going to deal with a few of the trends in the periodic table. And when we look at the trends on the periodic table, we're going to focus in on the representative elements. So remember, these are groups 1A, 2A, 3A, and then 4A all the way over to 8A, right? So the two leftmost columns and the 6 rightmost columns on the periodic table. So what we're going to see is that the properties of the elements, they change across a period in a predictable pattern as we traverse from left to right across the periodic table. So the first thing that we're going to take a look at here is the group number and the valence electrons. And we actually saw this last week in lab when we were looking at our ionic compounds. And as a quick reminder, the valence electrons are the outermost electrons in a particular atom. So again, for the representative elements, the number of valence electrons is simply equal to the group number. So once we can locate the element on the periodic table, we can quickly determine how many valence electrons we have. So for example, calcium is in group 2 or 2A, so it's got 2 valence electrons. Similarly, fluorine is in group 7, so it is going to have 7 valence electrons. Okay, so the trend there is fairly straightforward as we go across the periodic table. We can use a number of valence electrons to draw the Lewis symbols for each of the elements. And again, this is something that we saw last week in lab. So the Lewis symbol is where we represent the number of valence electrons as dots around the symbol, right? And a dot is exactly what it sounds like. It's just a dot that represents an electron. So for instance, we just saw calcium is in group 2, so it's got 2 valence electrons. So we have calcium with 2 dots around it. Similarly, fluorine has 7 valence electrons. It's in group 7. So it's going to have 7 dots around it. So 1, 2, 3, 4. We put 1 in each corner. And then if we have more than 4, then we start pairing up 5, 6, 7. So when you put your dots in the Lewis symbol, it doesn't really matter where the first several dots go. You just need to make sure that you put 1 in each corner around the symbol for the element. So in the case of magnesium, there are several options for where those first 2 electrons can go. The second trend we're going to take a look at is the trend in atomic size. And as we saw in class, we typically represent an atom as spherical. And we can talk about the atomic radius, which is just a distance represented by this yellow arrow. So obviously then, the larger the radius, the larger the atom is going to be. And the trend here in atomic radius is fairly straightforward. And just to remind you again, we're looking solely at the representative elements. So the trend is as follows. As you go from right to left across a period, the atomic radius increases, or the size increases. And then as you go from top to bottom in a group, the size increases as well. So for example, sodium is a larger atom than aluminum because sodium is further to the left. And then similarly, rubidium, Rb, is a larger atom than sodium. They're both in the same group, but rubidium is further down. The next trend we'll take a look at is the trend in ionization energy, which is the energy needed to remove one of the outermost electrons in a particular atom. So what this would mean then is if it's more difficult to remove an electron, it is going to take more energy. So in other words, the higher the ionization energy, the more difficult it is to remove that electron. Right, so the trend here is opposite to that of the atomic size. The trend for ionization energy is that it increases from bottom to top in a group, and then it increases across a period from left to right. So for instance, something like argon is going to have a higher ionization energy than something like aluminum. And similarly, sodium is going to have a higher ionization energy than something like cesium down here at the bottom of group 1. The next trend we'll take a look at is the trend in metallic character. And this trend would sort of go hand in hand with our initial look at the periodic table, where we first of all tried to identify where metals and nonmetals were located. So an element then with high metallic character is one that actually loses its valence electrons very easily, because as we've seen already, metals are things that tend to lose electrons. So if it's able to lose its electrons fairly easily, it's going to have a high metallic character. And what we're going to see is that the trend in metallic character is the same trend as the trend in atomic size, meaning that metallic character increases from right to left across the period and from top to bottom, right? And that should make sense because we said at the very beginning of the chapter that metals are typically found on the left side of the periodic table. So it would make sense that metallic character increases from right to left. So for example, something like sodium compared to something like cesium, cesium would be more metallic than sodium would because it's further down in the periodic table. And then sodium would have a higher metallic character than something like argon, which is over in group 8. Okay, and then table 4.12 in your textbook summarizes some of the, or the 4 of the periodic trends that we talked about. All right, so keep in mind, I mentioned this at the beginning, when it comes to the trends in the periodic table, we're looking at the representative elements, which are in the first 2 columns on the left and the 6 columns on the right.